Okay, so you guys have played a little bit with the chi-squared goodness of fit test. Now we're looking at a chi-squared test for association. This one is going to be different where when we did the goodness of fit test, we looked to see if the distribution of what we observed is the same as what it should have been expected. For a chi-squared test for association, you're trying to see if there is any relationship between two or more items. Not to be confused with a scatter plot, but this will be pretty straightforward. A couple things I want to show you how we do this. And also, this one here is extremely important. What do we do to do this on the calculator? And what does AP require? And I'm going to show you this one here especially because it's kind of funny. We'll do some work, and then we'll go backwards. Now, before we get into that, here's what I want you to see right now. For a chi-squared test for association, like I just said, it's to see if two variables are associated. A little bit like correlation, but even easier. So that's the first thing. It's a test to see if two variables are associated. So I always identify by a two-way table. And that right there is extremely important, this two-way table. Our ho and ha are going to be different. In the previous one we did before, the goodness to fit, we said ho was there is, our sample is correctly distributed. For ho, it rhymes with no. Ho is always no association. Ho, no association. Ha, obviously, is the opposite. There is an association. Ho, no, and then ha, there is. So this one here is extremely important. And again, as far as the work here, the four-step inference toolbox, steps for the chi-squared test for association. Step 1, as always, we'll identify population, we'll identify parameter. Ho, no. Ho, no association. And ha, there is an association. Step 2, SRS, our expected counts, again, has to be greater than or equal to 5. Somewhere here you want to put chi-squared test for association. And I'm going to show you about this expected counts piece here in a moment. Step 3 will be your work, and you'll notice I have this. Use calculate and draw. And we're going to do this again under stat tests. And then step 4, what does the answer mean? So, first things first. Let me show you a problem here. What we're going to end up doing is we enter our table under matrix A. And don't forget, it's always rows and columns here. And I'll show you how to enter into a matrix in case you don't remember. These two here, compute the test, and we'll calculate first, and we'll draw second to verify the p-value. And then I'll talk about this step 2 piece here in a moment. But here's what I want to do first, and I'll come back to this. This is from page 762, 1320. I want you to copy this information down. This is a two-way table. Again, one way, two-way, but then we can have multiple things going the other way. This is dealing with students smoking and students who don't smoke. And what I want you to do right now is either in your book, copy this table down in your notes. I want you to identify population and parameter. I want you to try to do step 1, which will be, again, identifying ho and ha. And if you can, start setting up step 2. But most important, get this information written down. And in a moment, I'm going to give you approximately 3 to 4 minutes to get this information down. And then I'll show you how to enter the data into your calculator, and we'll go from there. Okay. We're going to actually break this up into 2 parts real quickly. What I want us to do is I want to show you the steps that we would use to, first of all, to put this data into your calculator, again, using a matrix here, and also the steps. We're going to set up the toolbox, and we'll show you all the math. Now, first things first. Let's enter this data into our calculator. The way we do that is we want to put it into a matrix, which is right here. So we'll press second matrix. The first thing we have to do is edit. So go over to edit. We'll edit matrix A, and we'll type in our data. You can see I have the data typed in here: 400, 1380, 416, 1823, 188, and 1168. What I want to talk about next are the steps that we would use to do the 4-step inference toolbox. Step 1 remains the same. We have a population, which could be students and parents. And I believe they say the United States. And what we're trying to figure out, our parameter is there an association between smoking? And is there an association between smoking and parents / students? We're going to have our hypotheses here. Again, ho, no. There's no association between smoking and parents and students. Ha, there is an association between smoking and parents and students. Ho, for a hypothesis, for the chi-square test of association, don't forget, ho, no association. Ho is always no. Step 2, SRS. I want you to write this, expected. So we're going to have a matrix here. And I'll talk about what's going to go inside that matrix in a moment. All our expected values have to be greater than or equal to 5. This is real important, and AP does like to try to trick you here. All our expected values have to be greater than or equal to 5. Expected values will be given by the calculator. And don't forget, chi-squared test of association. Step 3, same as before, chi-squared is still observed minus expected, the quantity squared over expected, and we'll get a numerical answer. And then step 4 is because P is something with alpha, and then we'll say we either reject TOE or we fail to reject TOE, something like that. Now, here's what I want you to do. I want you to get this data in your matrix. I then want you to run a chi-squared test. Chi-squared test of association. Your observed should be matrix A. If it doesn't say matrix A, go to second matrix, and you can name it number 1, matrix A. Expected B. Here's what I want you to do. I want you to calculate, record down the chi-squared, and record down the p-value. And I also want you to draw it as well. So go ahead, give you about 4 minutes to do that, and then we'll come back together.